Let's look at note 7.6, log properties, and now we're going to condense. So using the product property backwards, we see that if you have log base b of m plus log base b of n, you can condense that to log base b of m times n. Now the bases have to be the same. Same goes for the quotient property. If you've got log base b of m minus log base b of n, we know that that can be combined into a single log base b of m divided by n. Last but not least, the power property states that if you have a number or letter out in front, that you can take that back up to the top to be an exponent. So let's write as a single log and simplify if possible. So looking at example number 1, if I've got log base 4 of 3 plus log base 4 of x, our product property states that if we've got a plus sign in between two like bases, that we can condense this to a single log base 4, and because of that plus, that means we're going to multiply 3 times x to be 3x. Okay. Similarly, if we have log base 2 of 1 minus log base 2 of 3, because of that minus sign in between, we know we would be using our quotient property, and that would make it condense to log base 2, and because of the minus sign, of 1 divided by 3. Okay. Last, using our power property here, if we've got something out in front, then we know we can take that something and put it back to be a power. So this is the same thing as log of a to the third power. Okay, let's look at some examples where we have to combine some properties. So number 4, we've got 2 log base 5 of 4 minus log base 5 of 10. So what I'm going to do first is recall that number in front will become an exponent, and the minus sign means I'll be using the quotient property. So I would have log base 5 of 4 squared over 10. Okay, because of the minus sign, I'm using quotient property. So here, simplify if possible, I can simplify this. So I know that this is the same as log base 5 of 16 over 10, and that actually simplifies even further to log base 5 of 8 over 5 when I reduce. Okay. Now, because I don't have enough room, I'm going to flip over. And example number 5. So if I have log base a of 48 minus 3 log base a of 2 minus log base a of 5, they all have the same bases, and I've got subtraction signs in between here. Okay, I've also got this number out in front on this one that's going to go back to being a power. So I know I'm going to have log base a of 48, and since the rest are minus signs, they both go on the bottom, of 2 to the third power is what that becomes, times 5. So I definitely need to simplify this one. So I've got log base a of 48 over 2 to the third is 8. So I've got 8 times 5. And then let's go further. I've got log base a of 48 over 40. And that can definitely reduce. So I would have log base a of 6 over 5 when I reduce fully. Okay, let's look at another example. So example 6. Let's look at 3 log base a of 2 plus 2 log base a of 3 minus log base a of 12. Okay, so a lot going on in this one. I've got 2 numbers that I need to bring back up to be powers. And that plus in between there means I'm going to multiply my first two on the numerator, and then the minus here means that one will go in the denominator. So I would have log base A of 2 to the third power. Because that plus, I'd have times 3 to the second power divided by, because that minus sign, the 12 goes in the denominator. So a lot of simplifying I need to do. Log base A of 8 times 9 over 12. So log base A of 72 over 12. And to simplify completely, that'd be log base A of 6. That reduces all the way down to a whole number. Okay, let's look at one more example. Number 7. All right, 6 log x to the third plus 2/3 log x to the 6th. So a couple of things going on this one. I've got these exponents that are going to have to come back up to the top, but I've already got exponents there. So hopefully you remember by your exponent properties, when I bring that up, log x to the third raised to the 6th power. Okay, and because that plus sign in between, that means I'm multiplying by x to the 6th raised to the 2/3 power. My properties of exponents state that when I've got a power raised to a power, like I do on both of these, that I multiply. So I've got log of x to the 3 times 6 is 18 times x to the 6 times 2/3 would become 4. So now when I multiply these two guys, when they have like bases, I should add. So I would have log base 10 of x to the 22nd power. And I can't go any further with that one.